All right. Hello. I wanted to do a stream. Let's see. Because I'm still working on. Well, I did a presentation on the demo. It went okay. It's really interesting, like the UX versus the technical complexity, and there's a very long distance between how technically things work compared to, like, if you distance yourself completely from the technical aspect. What I mean to say is it's really hard to merge the two concepts, the technical requirements to make this narrative of a PR work, yeah. So what I did is I did this presentation where I talked about how the current PR review works, where it's just a bunch of unordered files, and you have these hunks that guess the context of the changes as if they are conceptually tied together. Sometimes it's correct, sometimes it's not correct. And then at the end of the day, it's basically just removed lines and added lines. It's not very focused on the actual change you're making and why you're making it. And I talked about, like, a simple example of installing an npm package, using that to create a utility, use that utility to create some state management, and then use state to build the UI. And very often you go back and forward here, committing different things. And the goal is really the ability to retell the narrative of a final implementation, because you really know what you're doing when you're doing the actual implementation, and then actually allow reviewing a final implementation with an actual narrative. This is not a narrative. This is just a bunch of lines added and removed, grouped by best guess hunks and unordered files. One thing I do wonder, though, is if the files are ordered by which commit they were. Is it like alphabetical, or is it what commit they were part of? So if file A was part of the first commit, does that mean it's first? Which I hope it is. Anyways, this is not what we're going to do today. What we're actually going to do is I'm still not sure about the approach. And I thought maybe we can make like a very simple example here. Let's see. So let's imagine we have line 2. So we're going to have three commits basically. And on line 2, let's just use colors here. So line 2 is removed. And here line 6 is added, just to have something. Let's say that's, well, yeah, let's do this. And then for some reason we remove line 6 again over here. Well, no, let's do like line 8 or something. Now the thing is, we're just going to reason about moving these around. So if I were to move line, and we have to think about the order here. So we have this order now, which is, let's make this black, and then this is the actual order of those changes. And then we have 2, and then we have 8. Okay, so so this is about how we render it in the client. So if we were to move 2 over here, you could argue that if we were to remove that file first, then you suddenly don't add on line 6 anymore. You actually add on line 5, right? Because the diff tells you it's to be added to line 6, But now suddenly there is dynamically we remove one of the lines. But the thing is, this is not how it works now. Now it actually runs this array the same way. So it's still added to line 6, and then line 2 is removed, even though they're showed in this order. Because what we could do instead is that we could actually flip this around. We could do this, but then we would have to transpose this one into 5. Now it's suddenly added on line 5, and that's okay. The question is just if we need to do that, and should do that. In one sense, it makes more sense to do that. Maybe that's better, because now we have two different content. We have this mind-blowing thing where you add like line 2 being removed, but it still happens after this is added, which is not what you expect. Like, it's hard to reason about. But it simplifies. It allows you to just change the SHA of line 2 instead of actually transposing everything else in that file. But maybe that's exactly how it should work, because at the end of the day we have to transpose it. Because when we actually display this in the file, we actually do have to show that we have to transpose this diff. So even though it technically removed, added line 6 first and then removed line 2, like building the contents of the file, still the actual addition happened on line 5, like in terms of the diff, right? So for some reason, I was thinking it was better to split those two concepts, like producing the contents of the file because the argument has been always end up with the same contents. And I was thinking, like, if we always keep the let's call these hunks, if we always keep these hunks in order, we just change their SHA, then we will always get the same result. Yeah, so let's okay, so we did that, but what would happen now if we were to move this one over here? So that's not a biggie, right? Because it happens last anyways. But if I were to move this one over here now, that's allowed. Like, that's the question, is that allowed? From a UX perspective, it's so difficult, because now we're just thinking a single line. We're not thinking a conceptual change. Like, why would you ever want to move something from commit 3 to commit 1 without moving what you have in commit 2 to commit 1? Maybe it makes sense in certain scenarios, because the experience here could be like, you can only move these hunks one at a time. So I can only move this hunk over here, but I can't move it further until I move these ones over like this. That could be a constraint that you could argue makes sense. But if we were to do what I said, like, let's just move 8 over here. Now the problem now is that now it will add 6 and then it will remove 8 when looking at this file, right? But looking at this file, yeah, then it's that's the thing. Like here it's okay again, because now it doesn't change how this file works. But what if we were to change it around? So what if we did 2 here, and then we move 8 up here and 2 down here? What if we were to move 2 over here? Again, with the current approach, this works fine, though we have to transpose again the addition here. But now when you get to line, now when you display this one, we can't apply them in, if we apply them in order, wouldn't it be different? Because then you would first add 6, then remove 8, and then remove 2. I guess you end up with the same result. This is where I'm stuck now. I have a hard time reasoning about this. Yeah. And what would the consequence be if we were to move 2? So let's make a copy of this. So what if we created a new array where we have 2, and then this becomes 5, and now this becomes 7? Like, does it create the same result? That's my question. Like, does it actually produce the same result at the end of the day? Which I don't think it does. Or does it? So what if this was an import, this was a variable, and this was a comment? So if I remove the import here, I guess it's just fine in this simple example. What if we make it a tiny bit more complex? We need to have, what if we actually added something to line 1 as well? This happened here. Okay, so this is how it actually looks. So what if I were to move so this is a new import. I'm removing the import on line 2. Yeah, so this is where it gets tricky, right? So what if I move this one over here? It's still okay, because I'm still removing the import on the second line. But if I move it over here, I'm not removing the import anymore, right? I'm moving something else. Because now this is suddenly 1. And even if I do this approach where we add 6, if I'm going to look at this file, it's still wrong. Because if I add 6 first and then remove line 2, it's still wrong. So there has to be some sense of constraints in place here. So again, you could have a constraint that says, okay, you can move it over once, but as long as there are changes to that file. That is so this would have like an origin SHA of 3, and these would have like an origin SHA of 2. So what you could say is that if the origin SHA is not the same as the SHA, meaning now it has a SHA index of 2, but its origin is 3, if that file has others who has origin SHA 2, then those have to move. And that's the thing, like all of them doesn't really have to move. It's only this one that has to move first. To make it even more fun. So there's something, I'm thinking about this the wrong way. I'm sure of that. So what are the actual constraints I'm creating here? Now the thing that's important to build the same contents of the file. So when I move something, okay, maybe that is the constraint. So let's think about it a little bit differently. So what I can do is that I can always move, oh, maybe that's the thing. So I can always move okay, let's do that first. So I can always move left. Okay, so one really big constraint is you can only move. When I move something left, you have to move everything before it. So in this case, there's nothing before it, so I can move it over. But now if I want to move line 2 further, I also have to move line 1. That's a constraint. And now we don't do any transposition, which means that first it applies line 6, then it would apply line 1, and then it would remove line 2. But does that make sense in terms of user experience? Because what we also could do, I could move 2 over here, and then I can safely move 1 over here. Like, how would you tell the user about that constraint and why it's there? And my thought was like, if that's the constraint of moving left, would the constraint of moving right then be... so if I wanted to move 1 over here instead, let's imagine we do this. What if I wanted to add the import over here instead? So I move it right. That's perfectly fine. Yeah. Ja. En Carlsberg og noe snop. Ja, det er sikkert bra det. Nei. Ja. Det stemmer. Ja, det er... Just my partner asking me if I wanted anything in the grocery store. Okay. Now, yeah, so we move 1 over here. And in this case, why would we have to move 8? Do we have to move 8? Well, we have to move 8 in the sense that now 8 isn't valid anymore. Like, we could transpose it so it remove line 7 instead, but without transposing, that's what we're doing here. We would have to move 8 as well to make that valid in terms of building the contents. Because what would happen now is that it would, looking at this file, it would basically be the same as the previous one. And now here it would first add 1. Yeah, it will first add 1. Then it would remove line 8, and then it would remove line 2. So now we're still removing line 8 before we actually remove line 2, which is exactly what it was before as well. So that makes sense to me in terms of building the contents. So, okay, so the conclusion is, if the UX, how should we do this? With no transposing on moving hunks, moving left requires moving all before selected hunk, moving, okay, no transposing. Moving left requires all hunks before to follow. Moving right requires all hunks after to follow. Okay, so that means no transposing, or maybe we should just say only change SHA index. So if that's the only thing we do, we have this array of all the hunks. The only thing we want to do is to change the SHA index. Then we have to add the constraint of moving all previous hunks as well. Moving left and moving right, we have to bring all hunks after. To me, that seems like too big of a constraint. That seems too big of a constraint. What's interesting though is that when you kind of move through the hunks, you could actually like have colors on the before. Like the current one could have one color, and then you would put like a different color on the ones before and after to kind of indicate if you move left, these are all the ones you bring along, and if you move right, these are the ones you bring along. And you can still like split up hunks. But the point is, even if we do that, does that mean that does that solve the diff transposing as well? I think so, because we have this test here we can use, I think. So for example here, if I were to move this one left, that's perfectly fine. And I don't think there's any there's no transpose. Let's just comment out the transpose. Oh shit. Let's just comment out the transposing just to test that theory. Where is the transposing? Oh. Here we transpose. Okay, so let's just sort them, but we don't actually transpose. So now we have if I now move this left, like it looks exactly the same, right? No, oh, whoa. Yeah, that's the thing. Yeah, because the existing ones are now wrong in terms of the diff. So only changing the SHA index is not a good idea. Like, what should the goal be? I think the goal should really be that you only make a change one place, and then the file contents are produced correctly from that change, and the diff is produced correctly from that change. So what that would mean is if we move this stuff back, let's see, 1, 8 was also here. Okay, so what happens now if we, so only changing SHA index, that's it. Yeah, maybe we should add that. Requires transposing the diff. So even though the file contents are produced correctly with these constraints, we still have to transpose the diff. Because if I move this addition over here, even though it first adds on line 6 and then adds on line 1, like the actual diff isn't correct anymore, because now this is actually on line 7. So if we do transpose, what happens then? So let's take a look at actually transposing here. So what we're going to do, we're going to move 1 over here. And what needs to happen is that we go through the array, and we actually have to change the actual position of the thing so that this now becomes 1. We'll shove that in before, which means that we have to transpose this to 7 as this was an addition. But now what happens to everything else? Does it mean that we continue transposing 8 and 2? Like, we shouldn't need to do that. That's the thing. Like, does it mean that I only need to transpose the other hunks in the commit I'm moving into? Okay, so that is like moving 1 left. Change position in array and transpose other hunks and transpose later hunks in that SHA. Okay, so that's what I mean here. It's like if since this was line 1, I figure out at what position in the array do you need to be based on your start. So it needs to be before this one, and then I go through the rest of the changes on the same SHA, which is the one that was line 6, and now it becomes line 7. That means that when it produces that file, it will actually add line 1 first, and then add line 7. And then the diff will also be the same. But let's try other scenarios. So what if I were to move 2 over here? So let's make a copy of that as well. Now it means that 8 and 2 need to switch positions, which again means that the same rule applies. Figure out where the hunk should be in the array, which would be like in the second here, because it's line 2. And then go find the others and transpose them. And since this was a removal, this is transposed to line 7. Okay, but now a trickier one. What if I were to move this one to this place? With the same rule set applied? Oh. No, I didn't say. Sorry. Where were we? Okay, so we actually moved. Oh, shit. So now we actually moved all the way to the front. Oops. Oh, this should be 8 for now. So now we actually moved 2 over here. So what we need to change now is where is, with the same rule set applied, it means that we transpose this to 5. Now, the problem is the same, right? Because now we're just saying remove line 2. But we can't just remove line 2 because that's not the same line as here, because we added line 1 here. So that doesn't work. So you get into the same challenge. Yeah, this is so interesting. I like this exercise. It helps. So the problem here isn't solving this technically. The problem is making these constraints part of the user experience in a way that makes sense. So one way that's the tricky part, how to make sense of it. I'm leaning a lot towards because this split of transposing, only transposing the diff, it just adds complexity. If we didn't show diffs, if we were just creating file contents, then this would definitely be the easiest way to go. Well, given this, yeah, it has this constraint. So should we differentiate this? Because you could also, like, if this wasn't a removal, if this was an addition, and we would rather make this line 7, like, let's make this green just for the kick. Then we could actually move it here, because it's added to line 2, and now this is added to line 7. But when we get here, we can safely add to line 1, and this would still be represented on line 2 here. So it's the same. So that's the thing, like, maybe this is how to think about it. Like when this was moved, and let's make it green. So when we move it over here, nothing, like, does it, are there any hunks that actually affects this move? In this case, no, because there aren't any. In this case, no. Because it adds, if it was a removal on line 1, no, not then either. That I can't. Because why doesn't that affect the? So if I add something to line 2 here, it means this becomes on line 7, but this is still safely added on line 1. But if this is a removal, then the story changes. Because if I remove line 2, well, I guess what changes here is that this 8 isn't correct anymore. Like this needs to become 9. But that already happened when I moved it from... When I moved it from here to here, it already became 9. So how would is that how I should do it? Should I like look at the previous hunks and determine if that move is safe? Or does it mean that, or is there something I can use in terms of new and old? So deletions basically represents the old. So if I want to, so what this basically means is, like, as I said, it's like additions. So additions, so if you have a hunk that only has additions, that's like safe to move. And like you have to do transpose on the thing you move into on later hunks, but it doesn't matter. Like if yeah, that's also a thing. If I move out of this one, it means that it needs to be transposed back. But that's okay. What's that sound? It's just Oscar is sleeping outside. But is that the case? Like additions can be safely moved left and right using transpose, but removals can't. So again, if I move this over here, 8 becomes 9, perfectly fine. And it stays 9 when I move it over here, but now also 6 becomes 7, perfectly fine. But if that hunk has a removal, it means that, okay, I can safely move it over here, and I can transpose this to be line 7 instead. But when I move it over here again, where I have a previous hunk, it becomes a problem, because now I'm now I remove line 2, but line 2 is something else than what I removed here, because I added one line. So line 2 is something else. So I could do two things. I could transpose this one to be line 1, right? Because then it would actually remove the same line as it removed here. That was removed here. So maybe that's the point. Like, so when you move something left, you have to transpose the thing you move out first. So in this case, any hunk before this, there's no hunks before it, so there's no transposing of the hunk I'm moving. And then when it lands in the array at its position, it needs to transpose whatever comes after it in that SHA. In this case, moving 8 to 7. But when I move this again, now I actually have a hunk before it. So now I have to transpose this so that it fits with, in this case, it's transposed to line 1. Because that line doesn't exist on the previous one. And again, this is transposed to 5, because now we had the removal. And now we have the same line removed. Yeah, okay, this is interesting. So, transpose the hunk you move by previous hunks in same SHA. And then move to correct position in array. Transpose the hunks after the hunk you move in the same SHA. Transpose hunks after by the hunk you moved in to the same SHA. Okay, that makes sense to me. So what would happen if I move this one back? So let's imagine now this is 1. This became, let's just keep it 1, it was 2, 7, it was 8. And 5, it was 6. So what happens now when I move this back? Now it's line, yeah, now it's getting interesting. So now I'm saying there, yeah, okay, so this is like moving left, left. Okay, so transpose left, you have to do that thing. But what if you move right? Okay, so what if I move this right? Now let's try to revert this rule. So if I move right, I have to look at all hunks after the thing, which in this case would be Hello? Hi, Emma. So this would be I would transpose the hunk you move by previous, what's it called? Previous, after. later hunks in same SHA. So that will mean this would become 2 again. That one's correct at least. This one would become 2. But this is interesting because now I don't only transpose this one to fit with the stuff after this, I also have to transpose the stuff after. And then transpose. Maybe that was actually the case. No, that's the thing, right? Yeah, we'll talk about that. Transpose hunks after. Transpose the hunk you move by later hunks in same SHA. Transpose hunks after you moved from the same SHA. So that means since this was a removal, this goes back to 6 because we transpose that as well. And now this ends up here in the array. Transpose hunks after by the hunk you moved into the same SHA. Now that's not correct anymore, because those are already transposed. Yeah, well, in this case, they're already transposed. Right? Wait a minute. I moved it. Okay, let's do this again. Something fishier. Okay, so here we go. I'm moving it left. There were no previous hunks, so it doesn't get transposed. I move to the correct position in the array, and I transpose the hunks after. So now this happens on line 7 instead. And I move. Yeah, so that's what I'm missing here. Because now when I move this out, I need to transpose this to be 1 with the previous hunks. Move to correct. Yeah, but I'm missing this. I actually have to do this both places. So now since we moved this, oh, this is so interesting. Because now, how the fuck does this work? Does this mean that this goes back to 8 now? Because it still removed that line, so it's still it should still be at 7. But the problem now is that when I move it back, I'm saying that I should transpose. If this was like an addition that I moved right, then I would transpose this. But now I'm not supposed to transpose it. This is where it breaks for me. Does that still become 7 or does it become 8? So I remove line 1, something was added to line 5, something was added to line 1, and this removal is now still on 7. So if I were to move this back now this addition happens on line 6, which is perfectly fine. This becomes 2 again. But now I would expect me to transpose this again. But we can't do that because then suddenly it's 6, right? That's not the case. Yeah, this is breaking. Yeah, there's something like, I feel like there's something fundamental to this that I'm not understanding. So there's a different way to think about this. That's also possible because often it's more difficult to do like incremental changes. So what I mean is we could keep a reference to the original array. Yeah, so what we could, there's a different way to do this. So we could only change the SHA index. And we would just, that's what we do. We don't care about anything. We just change SHA indexes. Okay, so let's say this is not working. Let's do like a big X. This is definitely not working. As we see now, this is not really working either. There's a different way to do it. It's only change SHA index. And evaluate. So the way this would work. Oh shit, this was a... Can I make it... Why can't I? Oh my god, that's annoying. They have to be the same size. There we go. So let's move this back to 8, and this is 2. Happens over here. So we'll actually just change the SHA index you move to. And then what we do is produce the actual array for file creation and diffing. So what would happen here is that I guess we should use these arrays again. So let's imagine now that we have 6, 1, 8, 2. Okay. And let's add, this happens on SHA-1. This, oh. God damn it. Can I move that to the background? Send to back. What the fuck? Oh, that's super annoying. Oh, maybe I just had to. Okay, anyways. So this happens on 2. This happens on 2. And this happens on 3. So what I would do is, if I were to move 2 over here, I would just say this one now happens on 2. That's the only thing that happens in that original array. But I would perform an operation on this array every time we change SHA indexes. And that operation would, let's try to reason about that. Let's put these two aside so we have some more space. So what we would do here is we would look at, so we would go from the beginning and we would look at 6. Okay, you're on here. Okay, sorry, we have to do more here. So 1.1, 2.2, 2.2, 3.3. So this is like which SHA are you currently on and which SHA do you originally belong to. So now you're on 2, but you actually belong to 3. So what we could do here is that, okay, so this is like conceptually produced actual array. So let's just remove that. So what we would have to do first is we would have to sort the array. Sort array by current SHA index and line. So that means this thing. So this is what we change, and this is the thing we produce. Let's give it a color. So now what would happen here is that this would actually change places with this one, because it's by SHA index and line. So they're the same SHA index, but line 2 is before 8, so it's before that one in the array. Okay, so now we have that, and now we have to go. We do that sorting first, and then we go through the array again, and we look at, okay, we have line 6, the same SHA and origin SHA. It's okay. We don't have to do anything about that. The next one is on SHA-2. Its origin is also 2. We don't have to do anything about that. And then we see, okay, we're removing line 2. It has a later origin than where it currently is, and that means any SHA, any entry coming after this needs to be transposed. So we're basically saying, since, let's just think the SHA is different, the origin is different. So that means anything coming after this needs to be transposed. So now this will just become 7. And that's fine. Okay, so we did that. And now we change the original again, and we say, I actually want this one to be on 1. Oh, sorry. This one to be on 1. Let's see how this looks like now. We sorted it again. Sorry, this is, oh, sorry, this one is, yeah, let's make it look like its original one. So this is 8, this is still 2, but now it's 1, 3. We'll sort it. So now it changes place with this one. Okay. Oh, sorry. It's actually up here. Sorry. So now the tricky thing is identifying the scenario we had before. So this should actually be on line 1 now. How would we actually identify that? By going through the array. That's the thing. That's where I'm getting unsure. It's like, just to be clear, like when we move 2 over here, it's not line 2 we're removing anymore, because we added the one line here. It's actually line 1 we're removing. And even though we like sort this, like how would we understand? It's almost like for every entry, like this is where I kind of want to find the concept. Is it possible to look at every entry? because that's the thing. You're transposing other things related to the thing you moved, but you also have to transpose the thing you move. So this is the thing we move, and this is the stuff affected by the thing we moved. So transposing the things affected by the thing we moved is not a problem, because given that this already was transposed now to 1, that will mean that this one would become, we would have like a, since this has different SHA indexes, we would have like a removal transpose happening on this one, and we wouldn't have to do anything about these ones. Well, that's the thing, right? So this is the problem. Like, we transposed this one to remove the correct line. We had to transpose that one because now we have a removal in the file. And now you actually had to, like, you would have to transpose this one as well. Now this becomes 0. It doesn't make any sense, because this one is now 7. But what the hell happened to this one? There's something fundamental wrong about this. Because you could argue that, no, this is a different SHA index, so you shouldn't transpose this one. And it would still work, right? Because you would have removed line 1 over here, but now you have an addition on line 1. So you would get the same as adding that first line and then removing the second line. So that's perfectly fine. But this one shouldn't happen on 8 anymore. This one should actually happen on 7. Because originally that thing was over here, which means 8 is okay, but then we moved it over here, which means that now this isn't removed on 8 anymore, it's removed on 7, because we have this removal, and we still have this removal over here. But we're not going to transpose that one, but we are going to transpose this one. Like, it doesn't make any sense. So there's just something not correct about this. Like, without adding constraints. Or is there something I'm missing on this? Is there something I'm missing? Maybe the thing I'm missing here is that I have to stop thinking about or I have to start thinking about the line number. Maybe that's the missing piece here. I'm like only thinking about the SHA. So what if we flip this around? What if this, okay, we're going to do this again. What if this sorting wasn't on primarily on SHA? It was actually on line. So what if we did this instead? We sort all the changes made to all the lines in order. Let's see, this should be 8 for now. So what if we did this? And now we wanted to produce the contents of this thing. So let's focus on creating content. So if I did that, what I would do, I would filter this array, and I would be left with only 6 here, which is an addition. It would be there. if I were to produce the contents of this, let's forget about moving the 2 for now. I would filter on everything below or including this SHA, which would mean that we would have, in this case, we would have like 1, 6, and 8, which is a problem because it added 6 before it added 1. But okay, let's forget about that. Let's see if this actually helps the transposing. So what if we move 2 over here? We just moved 2. We just changed the SHA index to 2. And what this array isn't about producing content. It's about doing the transposing. So again, we have line 1. It doesn't have a diff in the SHA, so we'll just keep it as is. We're on line 2. It does have a change in the SHA, so we want to transpose everything. We'll store like this SHA has a transposition of 1 or -1, which is actually SHA-2. And then we see line 6. Well, that's actually a lower SHA than 2, so we don't transpose that. 8 is the same SHA that we have a transposition on, so let's do that. And it goes to 7. Okay, so now, so let's imagine we did that, and then we'll sort it again. So it's back to SHAs, and then we can produce the contents. So let's have like a third version of this. So we would go to this one. We would now do, this is 1, doop, doop. So we would then sort again, and we'll end up with this thing where we can look at each file, and it's in order, and it should be good. Yeah. Okay, but let's now imagine we actually move again. Like we move 2 over here. And again, we sort by this thing. And then we look at this one. Line 1 is on SHA-2. Does this help in any way? So this is what I'm thinking about. It's like we want this SHA-2 to become 1. And how can we make it 1? We could what we could do is like we could take the same array, we'd filter it on what lines are before this 2 and SHAs before its origin. So it would grab this one. So it would basically transpose by find all entries before this line on a SHA between where I am now and where I came from. And that would mean, oh, there's an addition there. Okay, we need to transpose you. Okay, I have to write that down. Find me all entries before this line between this SHA and my origin. So that's what would happen here. It would actually find this one. It's a lot of iteration though. Anyways, so this will become 1. And it's registered as a transpose on SHA-1, which is the other piece of logic, which means that this one would be transposed to 5. And yeah, this one would be 8 currently, but let's see what happens to it. And we want this to become 7 again, but our current logic doesn't transpose beyond its SHA. So this, even with the imaginative logic, it wouldn't actually touch this one, but it should. Okay. But I think I'm onto something. Because it's kind of like, as long as the SHA is the same as the origin SHA, we don't want to act on it. Like when we find it in the array, we don't want to act on it. But when we do find a difference, we do want to act on it. The question is, what do we want to do? So the question is how to transpose myself, which would be find me all entries before this line between this SHA and my origin. Then how to transpose others. What would that look like? So that would be find me all entries between after this line between this SHA and my origin. Oh, maybe this is it. So that would say, yeah, this is interesting. So if we were to do this query, we would actually get both 5 and we would get 8. And it would transpose both of them. Maybe that's it. Maybe this is the core of it. We have this array with the original contents. We every time we move something, we just go in, we change its SHA. And then we maybe we don't even need this intermediate thing. Maybe we don't even have to sort it. Maybe we could just keep it as is. Because what you're doing, you're just querying the same. You're querying the array anyways, because you don't really know. Yeah, maybe we don't have to sort it by line. Because it doesn't really matter when you. I don't think it matters when in the array you hit it. It's just that you actually hit it. Okay, so if we did exactly the same here on the original array, 6 1 1 1 2 2 2 1 3 and 8 2 2. So again here, same SHA and origin, same SHA and origin, different SHA and origin. Okay, how do I need to change? Find me all entries before this line between this SHA and my origin. So it kind of, maybe it even looks in the original array. It finds, it finds 6, this one. Well, I guess it needs to find it in the same array because it needs to transpose it within the same array. So it finds 6, it transposes it to 5, and it finds, it skips 1 because it's a line less, but it finds 8 because it's between 1 and 3. And it transposes that as well. And then it just continues. Yeah, so we don't have to sort it. Okay, this is interesting. You move to, we don't sort it, we just iterate array and find and act on each moved hunk. Yeah, whatever. Iterate array and act on each moved hunk. Hi, Siggy. Morning. Yeah, I've never had so much thought process going through the stream. It's I think maybe I have to upgrade my bandwidth just to get all the raw thoughts through to YouTube. But yeah, this has been such a mind-blowing experience for me, not like in the terms of mind-blowing as in impressive experience, but like mind-blowing in literally blowing my mind. But I really like where we got to here, because now we can say we have this new we now have this yeah, like, okay, so just change the shine next you move to yeah, I think we want to make a copy. Make a copy of the array and iterate, because we can have the original array can be changed to reflect what SHA indexes we moved, but when the transposition, make a transposition copy of the array, iterate and act on each moved hunk, where transpose the moved hunk by finding all entries before the line, between its SHA and its origin, and then transpose other hunks by finding all entries after the line between its the SHA and the origin. Maybe that's a better way. The SHA and the origin. Okay. So what I want to do is transposition copy. Let's call it that. Oh, wrong color. So what I want to do now, I want to do a couple of tests. like mental tests. So this is our rule set, and create a transposed array. The thing is, like, it seems quite heavy because we have to like reiterate the array all the time, but it would mean that like the one that would take most effort is the last version of the file, and that, like, there are limits to how many hunks you have in a PR on a single file. So I don't worry about that. Like, we can even put it in like a web worker if it would be cause issues. Anyways, what should we test first? Okay, so let's just do something. Let's move 6 over here. It probably breaks on the first try. What would happen here is that 6 is now on 2, 1, 2, 2, and this is still on 3, 3 now. Okay, we don't have to do this anymore. So we would go through the array. We would see, we would just change the SHA index of line 6 to be on SHA-2. We would go through, we would see that, okay, this first entry has a different origin SHA than its current SHA index, which means we have to see if we need to transpose it. And we do that by finding all entries before that line, between the SHA and the origin. So that means we need to find all lines between line 6 on SHA-1, like after line 6 on SHA-1, I think, and everything before line 6 on SHA-2, which is basically this one. And we need to transpose it. So now it doesn't happen on line 6 anymore. It actually happens on line 7, which is correct. That's transposing itself. And then we have to see, transpose the other hunks by finding all entries after the line between the SHA and the origin. So that means, again, it's, let's say it's line 6 now. So that means, yeah, I think this is not the best way to express it, but anyways, in this case, it would mean we have a line after line 6 on SHA-2, which is 8. And since this is an addition, this removal doesn't happen on line 8 anymore. It actually happens. Well, this is interesting. Because that doesn't happen on line 9 anymore. Like it does, it still happens on line 8. I think we need to rephrase this. Before, after the line, between, it's okay, but let's try to think how this actually works. So what we really did is that we kind of tried to collect all the entries from where it originated from to where it is. That's what we did. That's how it transposed itself. Okay, let's use that. Transpose by finding all entries from its origin position to its current position. That's basically what we're doing. And transpose. So we just collected, it was on line 6, whatever we would find up to this point, we would use to transpose it here. Now, okay, so this is interesting. There's a difference between I think there's a difference in the logic moving left and moving right. So that I had trouble like doing this because I changed my approach. Like suddenly I moved right, suddenly I moved left, and it broke all the time. And I think it's because it's actually a different set of rules. So let's do right transposition first. Because what happens now is that line 1 is still from its okay, no, we have to say let's be explicit. Right. So in this case we just have to transpose the moved hunk by finding all entries from its origin position to its current position. So that is everything that happened up to this point. So that means that this now happens on line 7. But now who are affected by this move? So this I find interesting. I'm using the wrong terms here because what we want to do now is that we want to, it's not like from its current position, because it's not really affected by lines after. Yeah, no, this is not right either. It's not like if we had, let's have an imaginary additional line 10 here, like this wouldn't actually affect this one. So that it's the wrong way to think about it. By finding all entries from its origin, finding all entries, it has to be lines before that. Before the line between its, or it has to be between its origin position to its current position. I think it has to be this. Transpose the moved hunk by finding all entries before the line between its origin position to its current position and transpose. So that would also be 1. And that is to transpose this one. It should go to 7. But now we have to figure out how does this change affect the others, and does it actually affect 8? No, I guess it doesn't. I guess it doesn't, because the other ranks by finding all after the line between the SHA and the origin. Between the SHA and the origin. After. Because we have added 2 of the same lines here, so 8 is exactly the same. So maybe this one only applies when you move twice. Okay, so let's just say that we do this by finding all entries after the line between its current SHA. I shouldn't say position, I should say SHA. Anyways, transpose the other hunks by finding all entries after the line between its origin. It's basically the same. So what between, yeah, so it means here between means the same SHA, right? But here between means not the same SHA. That's the confusing part of what I'm doing, at least how I think it should work, because I don't think this should be transposed. It's still line 8 that's being removed. Including its current SHA. Between its origin position, excluding from origin SHA, excluding its current SHA. Okay, so that makes sense here, but what if we did this? Now, let's apply the rules again. So again, it starts out like this, and we see that line 6 has been moved to SHA. Like, it's not the same SHA. So first we have to transpose itself. So we have to find all entries before the line from its origin SHA, including its current SHA, and transpose. So that means, okay, we hit this one, it should be on line 7, and we now hit 2 as well, which means it should go back to 6 because this was a removal, and that is actually correct. And then we have to see how does the others let's remove this one. How does the others change? So transpose the other hunks by finding all entries after the line from its origin SHA, excluding its current SHA, and transpose. So that basically means 8 is the only SHA between, it's the only lines after 6 between its origin and the current SHA, excluding its current SHA. It's 8. And that means that that removal doesn't happen on 8 anymore. It happens on 7, which is correct. Okay, I think this is it. Now let's try moving it left. That's the final test. And then, yeah, we won't have time to actually write the logic for this. But we will have time to at least conclude on it, and then I'll write some code and do some more streams on this. Okay. I really wonder, like, I've never gone to like university, never done academia, never been like this smart person. I'm very pragmatic about how I approach things. I'm very visual and stuff like that. But I do wonder, people, like really, really smart people tries to figure this stuff out, like pointing to operational transforms and stuff like that. Do they go through the same process? I wonder. Yeah, I'm really curious about that, because very often, like, you see these like really smart ideas coming out, and you just wonder, is it just a very, very smart person, or is it just a very what's it called, not confident, but like persistent person who just tweaks and pulls and reiterates constantly until they kind of find the thing. Anyways, I'm really curious if this works now. So let's do the 2 thingy again. So we wanted to move 2 over here. So let's, so 6 is still on the same SHA. It's now 2 that has moved. What we're going to do now, we're going to see if it needs to transpose itself. So find all entries before the line from its origin SHA, including its current SHA. Yeah, that's the thing. I think that's the difference. So this was right. I have a feeling this is going to be opposite when we move left. It's going to be excluding its current SHA and then including. That's my hunch. So let's reiterate. Transpose the moved hunk by finding all entries before the line from its origin SHA, excluding its current SHA, and transpose. So in this case, there's nothing there. So it doesn't need to transpose. But now we need to transpose other hunks by finding all entries after the line from its origin SHA, including its current SHA, which would hit 8, and it would transpose it to 7, which is correct. And now let's reset that, and let's move it to 2. Move it to 1. So again, we go through the array, we find this number 2, transpose the moved hunk by finding all entries before the line from its origin SHA, excluding its current SHA. And that means now this 1 is actually there, and it will transpose this to 1. And then transpose the other hunks by finding all entries after the line from its origin SHA, including its current SHA. So that means 6 will now become 5, and 8 will become 7. And that is correct, because now this became, we removed the same line as we did here, only we did it over here. This is now an addition on line 5 instead, which is correct. This addition here is, we don't touch this because it's before line 2, and this should still happen on line 1, but this one now has a previous deletion, which means that this deletion should now happen on 7. This is it. This has to be it. This is the rule set we're going to implement. It has to be this. Yeah. I'm happy about this. It's definitely worth trying. But yeah, Oscar is about to wake up. So I have to, I think I'll just finish here. But this was, for me, this was an amazing session. Like spending these, how long have I been streaming? Yeah, 1 hour and 40 minutes. Yeah, I definitely scratched my itch on this one. Great. Okay, I'll see. Might have some time later this evening. Famous last words. Yeah. Oh my god. But it makes sense, doesn't it? Don't answer that. Don't answer that. But yeah. Yeah. No, we're going to try this. And in terms of like, I'm trying to think about the logic as well. So what's really nice about this is in terms of the actual code, we have a simplification. Like we still just change the SHA, we already have logic for that. But now instead of doing instead of doing this, have this separation of the diff and the creation of the content, we just have this new version of the array, which changes when, so what would actually happen here? Yeah, so that's I guess it should just work. Like in terms of producing the contents, it would still add line 5 and then remove line 1. Yeah, I guess that's a question unanswered. Is like, does this mean it should does this mean it should be sorted? So the changes are applied in order. Or can it just stay the way it is? So in this case, we would have, it will be first, yeah, so yeah, that's the thing. I think this needs to be sorted. Because now we should really have added to line 6 first and then remove it. Yeah. Well, we don't have to sort, we don't have to sort by line. But we do have to, okay, so the final result of this. Okay, so just change the SHA index you move to. Yeah, we have to, okay, sorry. We have to sort it. But we don't sort it by, we do the transposition first. Let's see. Sort by line and SHA index. So the final result of this, sort it. Let's make it another color. So the final result of this is that this would be up here. Position sorted. Yes, because then we first remove line 1 and then we correctly add on line 5. And then, yeah. So that's the final thing. Okay, I'll stop there. Have a great weekend. I think I'll have time for a stream tomorrow. So either I have implemented something that I can show you, or we'll do it together and see what the result of this will be. The good thing now is that even though we talked about lines here, these lines actually represent hunks, and the additions and removals within each hunk is relative to the start of the hunk. Which means that when we start transposing the hunks, its relative changes, well, its changes is relative, so we don't have to mess around with that. The only thing that's might be a little bit difficult to identify is, as I say here, I say before the line and after the line. But a hunk isn't the start line. Like a hunk has an old start and a new start. And the actual changes are not necessarily on the start. Well, it isn't on the start. It's like between the start and the end somewhere. So I see a complexity there. But it might be simple because it's about like relative changes anyway. So we should be able to just create a transposition by looking at the hunk and doing like I'm doing now. I'm looking at I have something called new diff and old diff, where new diff is the additions and old diff is the removals, and I just check the length of them and then subtract, and then you kind of get the full how many lines does this hunk change the document with, and that's really what we care about. So I think that's okay, and then we'll just do it by, we think about like before the, let's just write hunk here. Yeah, all entries before the hunk. Yeah, exactly. And then that might seem limiting, but later you will be able to like split up hunks and stuff, even to like a single line. So that's not a worry. It's just having like the foundation for this to actually work. Cool. And now I really have to go. Thanks again. Bye.